This comes as a surprise. T1 is equal to T2 is a surprise for us. So that T1 is equal to T2, as we solved earlier by writing a lot of equations, that's come out very easily here.
A boat going downstream crossed a raft. An hour later it turned back and crossed the raft again. The distance between the two crossing points is 6 km. Find the flow velocity of the river.
Say this is the position of the raft at the moment the first crossing occurred. The river is flowing this way. So this is the position of the boat. And well, the boat is going downstream, so its speed will be VB plus VR, where VB is the speed related to water. So related to the banks, it will be VB plus VR. So the boat going downstream goes to say some B2, and the raft is somewhere here, say at R2 at that moment. The boat reverses its direction of motion, and then well, the next time when it crosses the raft, it is say raft is at R3. Boat is going this way. So the journey from B1 to B2 of the boat is at VB plus VR, and in the reverse direction it is VB minus VR. We are assuming that VB is more than VR, and that the fuel is being burnt at the same rate, so the speed of the boat related to water remains the same. So the time taken for the travel from B1 to B2 is given as 1 hour, and the distance R1 R3 is given as 6 km. From this information we will have to find the speed of the river. Now we could write some equations here. For example, B1 to B2 travel by the boat was at VB plus VR. So this is VB plus VR into, say, let's call that T1. T1 is given as 1 hour. And so R1 R2, the distance traveled with the raft in this time, is R1 R2. The raft is simply floating in water, so whatever is the speed of water, the raft goes with that speed. So it will be VR into T1. And then B2 B3, well, that's traveled at VB minus VR. So this B2 B3 is traveled at VB minus VR. We are assuming that VB is greater than VR. It's traveling to in this direction into, say, this is T2. And then this R1 R2 R3 is traveled at VR. Again, that time is T2. So the time the boat goes from B2 to B3, the raft goes from R2 to R3. So this is all we can write. So what do we see here? B1 B2 minus B2 B3 says B1 B2 minus B2 B3 equals R1 R2 plus R2 R3. If you notice the diagram I have drawn, there is a clue to the solution here actually. Just look at it carefully. Now let's substitute what we know here. We have assumed a number of parameters. VB, for example, we do not know. T2 we do not know. We have assumed parameters, and we have just written down the equations with the parameters we assumed. This is the usual style of solving a problem in physics. Don't have to focus on what is given. Just assume parameters and write the equations for the process that has been given to you. So B1 B2 is VB plus VR into T1, and then B2 B3 is VB minus VR into T2. This is equal to R1 R2 VR T1 and R2 R3 VR T2. You can see that this is VR T1, again this plus VR T2, so VR T1 and VR T2 get cancelled. Do you see that? This is VR T1 on this side, VR T1 on this side, minus VR into T2 minus VR T2, then plus VR T2, it gets cancelled with this. So we're getting something like VB into T1 minus VB into T2 equals 0, or T1 equals T2. T1 is given as 1 hour. This comes as a surprise. T1 is equal to T2 is a surprise for us. It's interesting that it's so. And we don't have to know VB for this. Now, T1 is equal to T2 and T1 is given as 1 hour, so T2 is 1 hour. So now you understand why R2 is the midpoint of R1 and R3. This is 1 hour travel at VR. This is also 1 hour travel at VR. So that's why I was saying there's a clue there. Now, so since R1 R3 is 6 kilometer, and that's been taken that's taken 2 hours for the raft to travel. So the river speed must be 3 kilometer per hour, right? The raft traveled from R1 to R3 a distance of 6 kilometers in 1 hour here and 1 hour here. That is 2 hours. This is it. Well, so nice. Well, routine solution, but yes, this is the way to solve. This is one way to solve. This time around, let's choose the reference frame of the raft. In this reference frame, the raft would be at rest, the river would not be flowing, the banks would be moving in the direction opposite to the river flow as seen by a raft. It's like you're traveling in a bus, the road seems to go back. So if you're in the raft, the banks of the river seem to move back. So the boat, crosses it first time, say at B1, and it's going downstream at VB. The speed related to the river is VB, right? So there is no downstream now. It travels this way at VB, and return also. Speed of the boat related to water has remained the same. So it is same VB again. So the boat goes for 1 hour this way at speed VB, and again at speed VB in the opposite direction to cross the raft second time. So the travel for one way and the other are same. So that T1 is equal to T2, as we solved earlier by writing a lot of equations. That's come out very easily here. But in this reference frame, the raft hasn't moved, right? So we got to go back to the ground observer and then see that the raft has moved in 2 hours 6 kilometer. So 6 kilometers in 2 hours is 3 kilometer per hour. That's nice. So we could get time from the reference frame of the raft and come back to the ground observer to get the speed of the flow of the river. Now we can choose time to solve for time in any of the reference frames. This is okay in classical mechanics where time is not relativistic. Time interval between events is same for all observers in classical physics, where speeds are not close to speed of light. Well, when you approach speeds of light, time also becomes relativistic. The interval between events depends on the observer's speed, but that's not our case here. We're doing very simple mechanics, classical physics. So what's interesting here is you can switch reference frames and then solve the problem. So this is something which you should learn. Well, maybe this trick would be useful. And you could have put the observer in the boat too, but then boat speed is changing, so it becomes a little messy. I suggest you try it. But something is moving uniformly as seen by the ground observer at VR, the raft. So put an observer there and things become really, really simple.